In skill practice 4, we're going to work with the 30, 60, 90 triangle. I'm going to draw and label that. In a 45, 45, 90 triangle, you're dealing with the root of 2, but in a 30, 60, 90, you're dealing with the root of 3. So please make sure you keep those separate. The sine of 30 degrees is equal to opposite, which is 1, over hypotenuse, which is 2. The cosine of 30 degrees is equal to the adjacent, root 3, over the hypotenuse of 2. And the tangent of 30 degrees is equal to the opposite of 1 over the adjacent of root 3, which of course we rationalize, and we get root 3 over 3. If we're simplifying these expressions of cotangent and 60 degrees and cotangent of 30 degrees, we need to know what those cotangents are. Using the triangle from above, the cotangent, remember, of theta is equal to reciprocal of tangent, which is adjacent over opposite. So if we're talking about cotangent of 60 degrees, that is adjacent, which is 1, over the opposite, which is root 3. So we have 1 over root 3 minus the cotangent of 30 degrees, which is root 3 over 1. I'm going to rationalize that first one, which is root 3 over 3 minus root 3. Now I'm going to find a common denominator, so I'm going to multiply this second fraction by 3 over 3, which gives me root 3 over 3 minus 3 root 3 over 3. That's essentially 1 root 3 here. So I have 1 minus 3 is negative 2 root 3 over 3 for question A. Question B, sine of pi over 3 and pi over 6, cosine of pi over 3 and pi over 6. You need to remember what pi over 3 represents. Now, you can take pi over 3 and multiply that by 180 over pi to get it into degrees to make yourself familiar that this is 60 degrees. Pi over 6 times 180 over pi simplifies to 30 degrees. Now, you won't want to be doing that. You will know pi over 3 is 60 degrees. You will know pi over 6 is 30 degrees because you'll use it so much. But right now, I just wanted to show you so that we can use that triangle that we have above. So the sine of 60 degrees is root 3 over 2. The cosine of pi over 6 is the cosine of 30 degrees, which is root 3 over 2, plus the cosine of pi over 3. The cosine of 60 degrees is 1 over 2, and the sine of 30 degrees is also 1 over 2. Root 3 times root 3 is 3, 2 times 2 is 4, 1/2 times 1/2 is 1/4, because 1 times 1 is 1, and 2 times 2 is 4. So 3/4 plus 1/4 gives me 4/4, or 1 whole. Skill practice 6, we have sine and cosine, and we want to use the reciprocal and quotient identities to find values of other trigonometric functions. So for sine and cosine here, I know that sine is the reciprocal of cosecant, and cosine is the reciprocal of secant. Now, I want to find all other trigonometric functions. I'm going to write these out. In this case, we're not labeling a triangle here. We are just supposed to use the identities. Tangent of beta is equal to sine of beta over cosine of beta, which is a quotient identity. That's equal to 3/7 over 2 root 10 sevenths. Division of fractions says I can multiply by the reciprocal, so I'm going to take 3 over 7 times 7 over 2 root 10. That gives me 3 over 2 root 10, but I have to rationalize that denominator. I get 3 root 10 over 2 times 10, or 3 root 10 over 20. Cotangent is similar. It's the cosine of beta over the sine of beta, or 2 root 10 over 7 divided by 3 over 7. Division of fractions, again, says I multiply by the reciprocal, which gives me 2 root 10 over 3. I still need to find secant and cosecant. Cosecant of beta is 1 over sine of beta, or just the reciprocal, 7 over 3. Secant of beta is 1 over cosine of beta, or again the reciprocal, so I have 7 over 2 root 10. Rationalizing the denominator, we get 7 root 10 over 20. Skill practice 7 gives us cosecant theta for an acute angle, and I want to find cotangent theta. I don't really want to use reciprocal identities for that. I want to use the Pythagorean identity, and the Pythagorean identity that relates the two of these is that 1 plus cotangent squared of theta is equal to cosecant squared of theta. This means that the cotangent squared of theta is equal to cosecant squared of theta minus 1, or the cotangent of theta is equal to cosecant squared, which is 5/4 squared, minus 1. 5 times 5 is 25, 4 times 4 is 16, and I'm going to turn this into 16/16 to find a common denominator. The cotangent of theta is then the square root of 25 minus 16 is 9/16, and those happen to be nice, perfect squares. The square root of 9 over the square root of 16, or 3/4. Now, notice that I used the positive square root. You know, whenever you're doing an equation where you have x squared equals 3 and you square root both sides, both positive and negative root 3 work for that. But when we're talking about angle measures here and we have positives, you are only dealing with the positive there, since 5 and 4 were positive. We will get into negatives a little bit later. We want to find a cofunction of the same value for degrees and for pi. So remember that tangent is a cofunction to cotangent. So the tangent of a degree is equal to cotangent of 90 minus that angle measurement. Now I know that root 2 minus 1 is the value. I'm not really doing anything with that. I just need to find another trigonometric identity that has that same root 2 minus 1. So I'm going to take the cotangent of 90 degrees minus 22.5 degrees, and I'm going to get that as the cotangent of 67.5 degrees is the same thing as square root 2 minus 1. Secant and cosecant are cofunctions. The secant of theta is equal to the cosecant of pi over 2 minus theta. And I'm using pi over 2 here because the question was given to me in radians, so I want to keep it in radians. This means that the secant of theta is equal to the cosecant of pi over 2 minus pi over 3. I want to find a common denominator. So I'm going to multiply the first one by 3 and the second one by 2, 3 over 3 and 2 over 2. The secant of theta is also equal to the cosecant of 3 pi over 6 minus 2 pi over 6, or cosecant pi over 6. That's equal to 2. Skill practice 9 asks us to use a calculator. I'm going to make sure that I'm in degrees for A and B, and I'm going to be in radians for C and D. Notice that there is a symbol for degrees in both A and B. So even though tangent does not have a pi, it is in radians because there is no degree given. So it's really important that when you're talking about degrees, you use the degree symbol, and when you're talking about radians, you use the radian symbol. With the sine of 46.3 degrees, I would go into my calculator, I would press the sine button, and then I would enter 46.3, gives me a value rounded to 4 decimal places of 0.7230. There is in the Texas Instruments 8384, you can get to minutes and seconds. So you could actually enter cosecant 11 degrees 8 minutes by using the second apps feature. So if you press the second button and then you press the apps button, option 1 is degrees, option 2 is minutes. For seconds though, you would need to do alpha and the plus sign to get seconds. So you don't have to necessarily convert this into decimal mode before you enter this into your calculator. Finding the cosecant though, there is no cosecant button on the calculator. You need to do 1 over sine. So I would do 1 in my calculator. This is what I would enter. I would do 1 division symbol sine, and then I would enter 11, and then use the second button to get apps, and then enter 1 for degrees. Then I would press the number 8, and then I would go back to apps again, and I would enter 2 for minutes, and then I would click enter. And that's going to give me 5.1789. I would need to change my calculator into radians now, and so I would press mode and hit radians. 1.4, the tangent of 1.4 is 5.7979. Cotangent, again, I can't do that, so I need to use the reciprocal. So I would do 1 divided by the tangent of pi over 8. And again, don't use 3.14, use the actual pi symbol in your calculator, which is above if you press the second button and then use the caret symbol. So the second and the caret symbol will give you pi. And that is 2.4142.